So since you are late, I am going to correct the test. So we have the function fx defined on R by fx equals e power to e power x over ex plus 1 minus x, and c is its curve in an orthonormal system. 1a limit as x tends to minus infinity للfx, and we have to show that the line D1 with the equation y equal minus x is an asymptote. So limit as part 1, limit as x tends to minus infinity of fx. We replace each x by minus infinity, بصير e to the minus infinity over e to the minus infinity minus minus infinity, it becomes plus infinity. As you know, e to the minus infinity is 0 over 0 plus 1, we get plus infinity. Now to verify that the line D1 is an asymptote, so we have to determine the limit as x tends to minus infinity of fx minus yd1 equals limit as x tends to minus infinity fx, this is fx, minus yd1, it becomes plus x minus x, 0. Then the limit, then d1, y equal minus x is an oblique asymptote to c at minus infinity. Part 2, we are going to calculate the limit as x tends to plus infinity of fx. And we have to verify that the line D2 with equation y equals minus x plus 2 is an asymptote to C. So limit as x tends to plus infinity of fx, we replace each x by infinity. It becomes e to the infinity over e to the infinity plus 1 minus infinity. E to the infinity is infinity, so infinity over infinity minus infinity. This infinity over infinity is indeterminate. We apply Hopital's rule. Then the limit as x tends to plus infinity of fx, by using Hopital's rule, it is equal limit as x tends to plus infinity. Derivative of 2ex is 2ex over ex, derivative of ex plus 1. ex with ex 0, 1, half 1. 2 minus infinity is minus infinity. Now to verify that the line D2 of equation minus x plus 2 is an oblique asymptote, we find the limit fx minus yd2. Then the limit as x tends to plus infinity fx minus yd2, this is fx minus yd2. We apply Hopital's rule, equal limit as x tends to plus infinity. هاي بيطلع infinity over infinity, we apply Hopital's rule. So it is 2ex over ex, ex with ex simplified. So 2 minus 2 equal to 0. Then we say that the line D2 with the equation y equal minus x plus 2 is an oblique asymptote to C at plus infinity. Part 3. Part 3, to show that the line C is included between D1 and D2, to verify that the line C is included between D1 and D2, we have to prove that we have to study the position between C and D1 and the position between C and D2. We have to study the position between C and D1 and the position between C and D2. First, we study the position between fx minus yd1 is 2ex over ex plus 1. Its sign is positive. Then C is above D1. Fx minus yd2 equals 2ex over ex plus 1 minus 2. We take the LCM, it becomes 2ex minus 2ex minus 2 over ex plus 1. It will be less than 0, minus 2 over less than 0, then we say that C is below D2. So here C is above D1 and C is below D2 means C is included between D1 and D2. C is included between D1 and D2. C is included between D1 and D2. Part 4. Show that F is strictly decreasing and set up the table of variations. For the function to be decreasing, its derivative should be negative. So we have to calculate f prime x. Part 4. Okay, f prime, this is fx equal to ex over ex minus 1 minus x. F prime x equals u prime v minus v prime u over v squared. Derivative of minus x is minus 1. U prime derivative of 2ex is 2ex into v into ex plus 1 minus v prime derivative of ex plus 1 is ex into 2ex over v square over ex plus 1 square minus 1. Expand 2ex times ex, you add the powers. It is 2e power 2x plus 2ex minus 2e power 2x over ex plus 1 squared. So e power 2x minus 2e power 2x, 0. It will remain 2ex over ex plus 1 squared minus 1. We take the LCM, 2ex minus ex plus 1 squared. Now we expand 2ex. It becomes e power 2x times minus e power 2x. 2ab is 2ex times minus is minus 2ex. 1 square is 1 times 1 minus is minus 1. So 2ex minus 2ex is minus e power 2x minus 1 over ex plus 1 square, which is negative. Since e is negative, well, minus 1 is negative, minus e is negative. So the function f is strictly decreasing. Now, table of variations, x, f prime x, fx. Domain of definition is minus infinity plus infinity. It is decreased, so f prime x is negative, decreasing. Al minus infinity, the limit is plus infinity, it is determined. And al plus infinity, it is minus infinity. Here we have d1 is an oblique asymptote. Here we have d2 is an oblique asymptote. Part 5. Part 5. Show that f double prime of x equals in that form, and show that the point W01 is a point of inflection. is a point of inflection for C. So mostly all of you have done this part not correct. Part 5. So f prime x, this is f prime x, equals minus e power 2x minus 1 over ex plus 1 square. U prime derivative of minus e power 2x is minus 2e power 2x into ex plus 1 square. Now derivative of ex plus 1 square, derivative of ex plus 1 square, if we need to find the derivative, first derivative power بيصير تحت 2 ex plus 1 to the power 1 times the derivative of ex plus 1 times ex. Mostly all of you forget to put times ex. So this is v prime times u minus e power 2x minus 1 over ex plus 1 to the power 4. I take 2ex plus 1 common. Remains here minus e power 2x into ex plus 1 minus, is if I take 2ex plus 1 common, still we have ex into minus e power 2x minus 1 over ex plus 1 to the power 4. هيدا بيروح مع هيدا بضل هون cube. بضل still we have 2. We expand. Minus e power 2x times e to the x is minus e power 3x minus e power 2x plus e power 3x plus ex. هيدا وهيدا simplified. I take ex common, remains minus ex plus 1 over ex plus 1 cube. This is the second derivative. To find the point of inflection, we have to solve f double prime x equal to 0. F double prime x equal to 0, it means that the numerator equal to 0, 2ex into 1 minus ex equal to 0, 1 minus ex equal to 0. It means that ex equals 1. So x equals ln 1, x equal to 0. As I say always, you have to show that the second derivative changes sign. To show the second derivative changes sign, this is second derivative of x minus infinity plus infinity. This is 0. Now, here I put 0 at the 0, second derivative is 0. To know the sign, if I take 1, 1 is in this interval. If I replace it in the second derivative, we will get 2e, which is positive, into 1 minus e, which is negative. Here negative, and here it is positive. Now, for x equal 0, f of 0 equal 1. So W01 is a point of inflection. Part 6. Show that W is a center of symmetry. Show that W is a center of symmetry for C. The rule for center of symmetry is f into 2a minus x plus fx equal to b. A is 0, هيدا A هي 0. B is 1, then f of minus x plus fx equal to. F of minus x, we replace each x by minus x. It will be e to the minus x over e to the minus x plus 1 plus x. e to the minus x بننزله لتحت بيصير times e to the x plus x. هيدا كانت minus x، حطينا محل ال x minus بيصير plus x. هيدا ال e نزل لتحت مثل ما قلنا، we expand بيصير 2 e to the x times e to the minus x is 1 plus e to the x plus x. So f of minus x plus fx equals, this is f of minus x, this is plus fx, same LCM, 1 plus ex, we will get 2 plus 2ex, it is equals, take 2 common, 2 into 1 plus ex over 1 plus ex, we get 2, which is 2b. So f of minus x plus fx equals 2. Therefore, W is a center of symmetry. Seven. Show that the equation fx equals 0 has one root alpha and verify that alpha is between 1.6 and 1.7. Verify that alpha is between 1.6 and 1.7. Now, to verify f x equal to 0, we say that f is continuous and f is strictly decreasing over 1.6, 1.7. F is continuous and strictly decreasing over 1.6, 1.7. You have to mention this. F is continuous and strictly decreasing. Or we can say F is decreasing from plus infinity to minus infinity. Then its curve cuts the x-axis at one point. So fx equal to 0 has one root. To verify alpha is between 1.6 and 1.7, f of 1.6 is 0.064, which is positive. F of 1.7 is minus 8.93 times 10 to the power minus 3, which is negative. Then alpha is between 1.6 and 1.7. Part 8. Draw D1, D2, and C. Draw D1, D2, and C. Now to draw D1, that part, okay. To draw D1, y equal minus x, y equal minus x, for x equal to 0, y equal to 0, for x equal minus 1, y equal 1. This is the first asymptote, D1, the asymptote at minus infinity. The second asymptote, y equal minus x plus 2. For x equal 0, y equal 2. And for x equal 2, y equal to 0, we draw the second asymptote. We have the point W, which of coordinates 0, 1 is a center of symmetry. So at minus infinity, D1, not D2, D1 is an asymptote and C is above D1. It is decreasing. It cuts the x-axis at alpha between 1.6 and 1.7. Then it goes near the second oblique asymptote D2. Part 9. Show that gx equal len fx, domain of definition. We are going to calculate the domain of definition of the function gx equals len fx. Either all of you have done it not correct. So everything inside ln should be positive. So fx should be positive. Gx equal len fx, and fx is positive. Fx is positive. Graphically, fx positive من minus infinity للألفا. X belongs to minus infinity alpha. Then, part A, calculate the integral of ex over ex plus 1 dx. It is of the form du over u, du. وهذه ex dx is du. du over u equals len u. So, part 10, it is of the form du على u, it is len u, it is equal len ex plus 1. The last part about the calculation of area. Part B, denote by A alpha the area of the domain limited by C, D2, and the ordinate axis. The ordinate axis يعني x equal to 0. And the line of equation x equal alpha. So the area between a curve and a line, since D2 is above C, we say that the area, part B, area equal integral من 0 لألفا y d2 minus fx dx. So the area equals y d2 is minus x plus 2 minus fx, it becomes minus 2ex over ex plus 1 plus x. X minus x, 0. 2, integral of 2 is 2x. Integral of 2ex over ex plus 1, it is 2 len ex plus 1 between 0 and alpha. So it is equal to alpha minus 2 len e to the alpha plus 1. 2 alpha minus len e to the alpha plus 1. First time we replace x by alpha. Minus, second time we replace x by 0, but here 0 minus 2 len 2. It will become 2 alpha minus len e to the alpha plus 1 plus 2 len 2. But we don't reach the result. We have to remember that f of alpha equal to 0. It means 2e to the alpha over e to the alpha plus 1 minus alpha equal to 0. I have to determine e alpha in terms of alpha. then 2e alpha over e alpha plus 1 equal alpha. Then alpha e to the alpha plus alpha cross multiplication equal to e to the alpha. E to the alpha to one side. E to the alpha into alpha minus 2 equal minus alpha. E to the alpha equal minus alpha over alpha minus 2. So it will be 2 alpha minus 2 ln minus alpha على alpha minus 2 plus 1. حطيت محل ال e to the alpha its value. We take the LCM here. It will becomes alpha minus 2. I change the sign, this is 2 over 2 minus alpha. It will become 2 alpha minus 2 ln 2. هذا ln A over B is ln A minus ln B plus 2 ln minus 2 alpha plus 2 ln 2. I take 2 common and it will be remains alpha plus ln 2 minus alpha square units of area.